Right, lesson 1-8, optimizations with linear programming. Graph each system of inequalities, name the coordinates of the vertices of the feasible region, and then you find the maximum and the minimum values of the given function. Okay, now this is the function that we need to graph. Right, here it is. Okay, let's graph this one first. Y greater or equal to 1 and y smaller or equal to 4. Okay, we have one of this line right here, and the 4 is right here. Let me draw this line. Alright, now when you graph inequality, you need to shade it. So I will give you the final shade later once I'm done with all of this graphing. So for this moment, keep in mind the region of solution is in between this line. So you shade in between these two lines. Now let's continue to graph this line right here. Now to graph this line, let's try to simplify this one first. So I will have 4y greater than or equal to 6x minus 32. Let's simplify this by 4. I have y greater than or equal to 6 divided by 4. You have 6 over 4, or you have 3 over 2x. And then minus 32 divided by 4, you have 8. Okay? 32 divided by 4 is you have 8. Now after that, let's do the graphing. Now when you graph this line, let me transform this into simpler term first. Y greater than or equal to 3 over 2x minus 8. Alright, this line. Let's get a table value for this one. X and y, table value. Now when x 0, y is negative 8. But I don't want to use all the way to negative 8, you know. I didn't draw the graph here for that small number negative 8. So let me try to find something else that make x, if x equal to 2, 3, negative 5. Now let me make x equal to 4. Okay, so when my x is 4, 4 times 2, 4 times 3, 12 divided by 2 is 6. 6 minus 8, you got minus 2. So if my x is 8, you have 12. Actually, let me do the division first. 8 divided by 2, you have 4. 4 multiplied by 3, you got 12. 12 minus 8, you get 4. So now you have 2 points to graph the line. So y 4, x negative 2. So by 4, x 4, y negative 2. So you have x 4, y negative 2 somewhere here. That's 1 point. And then when your x is 8, your y is 4 somewhere here. So when you have that, let's draw the line. Okay, now where did you do the shading? Okay, so look at the sign right here, y greater than. So when it is greater than, you shade above the line. Greater than, shade above the line. So this is the region of solution. You shade above the line. Okay, now let's go to our last line. Let me try to convert this into simpler term. First, you have y greater than or equal to. You divide this one by 2, you have a negative 1 over 2x and you also have plus 2. So you have this line. You need to graph y greater than or equal to -1/2x and then plus 2. Find table values of this equation. Okay, x and y. Now if x is 0, 0, y is 2. Now when your x is 2, say x is 2, 2 times 1, 2. -2 divided by 2, you have 1. -1 plus 2, you get 1. So let's graph that line. So 0, y2. When your x is 2, your y is 1. Okay, when you have that, let's graph. Well. Should be on the point. Why it's not like that? 2. Oh, sorry, I make mistake on that. That's why. Should be here. 2, 2, 1. Oh, I make it the wrong point. This is -1. No. 2, 1 here. That's why. So why is something wrong with this? Okay. Now, the region, shading region, this is greater than or equal to, looking at the regional equation, is greater than or equal to, so you shade above the line. Now, it seems like right now we have a common shading region. So let me erase this one and give you a proper shading of the answer. So you have another point right here as the vertices. So this is the shading region. Oh, sorry, not this one. Now we have 4 vertices actually. You have 1, 2, 3, and 4. Now, this is all the section of the solution region. After that, let's answer the question. Name the coordinate of each vertices. Okay, let's say, well, you can represent letter or you don't want to represent letter, that's up to you. Let's just name it right away. Let's start from here, or just put A, B, C, easier. A, B, C, and D. Okay, now at point A, what do we have here? So this you have, starting from here, you have -4, and then you have 1, 2, 3, 4, -4 and 4. And then for point B, you have this one 8, and then 1, 2, 3, 4, 8 and 4. For point C, you have this one as 6 and then 1, and the last one for the last vertex is D, which is 2 and 1. Okay, now after that you need to find the maximum and the minimum values of the given function. Now to do so, you need to substitute each of these vertices into this equation down here. Let's start with A first. Start with A. So you have this one as -6, and you times x, which is -4, and then you plus 3 times y, which is 4. Let me do this one. So you have -6 times -6 times -4, you have 24, so 24, and then you plus with 12, that gives you 36. That's for point A, 36. After that, let's go on to point B. Point B, you have -6 multiplied by this one, 8, and then plus with 3 times 4. So you have -6 times 8, and then you plus 12, that gives you -36. So that point C, -6 times 6, and then you plus with 3 times 4. So 6 times 6 is -6. -36, sorry, -36, you minus 12, that give you plus 12, sorry, not minus. You plus 12, that give you -24. And then the last point, which is last for this, which is -6, and you times by x, which is 2, and then 3 plus 3. Oh, sorry, this is not, this is times 1, my mistake. So you have -36 plus 1, -33. Plus 1, sorry, plus 3. This one here, -12 plus 3 equal to -9. So among these 4 vertices, we can let's find the maximum and minimum value of this inequality, system of inequality. So from here, so therefore this is the maximum, this is the biggest number, 36, and the negative number, this is the minimum number. So the maximum, let me write this one for you, maximum value